This video will not be about one particular standard or size, dimension, or group of metal tubing. It'll be about the idea of it, and it will have links below in the description that lead to everything you see on the screen as much as possible. Warning, even companies that make this stuff, if they do a spreadsheet this big that you're looking at, will make occasional mistakes, and that is to be expected. Many of these sites go out of their way to make sure they don't waste your time or theirs by providing this information gratis, and in some cases, especially on this website that I'm linking to here, they'll even go to the effort of making sure the website will show you their current prices and how much it costs per foot and how much it weighs. This is a good example because it gives you a clue as to the industry we're dealing with. It includes the following. The pipe schedule name refers to mostly what thickness of metal tubing was used to make that pipe, or gauge, or the ratio of its thickness to its outer diameter or inner diameter, or its pressure rating. You may have noticed there's no standard here, so let's skip all that. For instance, in the 12-inch, yes, that's really 12-inch diameter piping, that's actually almost 13 inches, you find out that there are various schedules, or standards, or pressure ratings, or strengths. They start at number 5, 10, 20, 30, 40, 80, 60, 80 again, what? 100, 120, 140, and 160, then include things such as extra strong, which is schedule 120, or it's schedule 150, depending on where you're looking. And they'll have standard, which will be schedule 40 most of the time, but that might actually be the wrong thing, and it may be standard is schedule 30. Yes, there are no standards here, but this website goes out of its way to tell you at what diameters are considered standard with what thicknesses. For instance, once you get to really truly huge diameters, the schedule that's called standard will not be schedule 40. Obviously, it will be some other standard. Some of them skip all that and tell you wall thickness and diameters, but then you don't know whether or not those are the standards that are used in the industry. Some of this is based on the outer diameters being close enough to each other for you to be able to thread them together using pipe fittings. Some of them are based on the inner diameter or the outer diameter being the standard. If it says pipe, that means it's not really going to have a standard except for the connectors you can use to connect them to each other, which is what they base it on. If it says tubing, the standards for the dimensions are often based on measuring inner or outer diameter only, or they will be very strictly saying literally the number directly in the middle between the outside and inside. It could be anything. So let's show a few pages about this. Now this one's going to iblink.com in Pakistan, and they have a habit of putting up very informative data sources. I'm not endorsing the company. I'm just saying that any company that goes out of its way not to waste my time or theirs deserves money, and the rest can go burn in hell. Let's continue. This is a 138-page tubing and pipe data file with an exhaustive list of every damn thing you'd ever want to know about piping and tubing at ejmetals.com, PDF indexer, PDFs, tubing and pipe PDF file that just covers the whole fucking subject. Carbon, steel, stainless, aluminum. I suppose they have something in here made out of parsnips. It's mostly an aircraft alloy steel company, but they also do roll cages for cars. And they like being very specific because it wastes time less. Just saying. Here is the 90,000 pounds per square inch rated 4130 chrome alloy steel that refers to how much chrome and other elements are in it and carbon levels. Round seamless tubing chart on aircraft spruce for making aircraft framing tubing. Any kind you want. One of the versions of it from 2019, apparently, aka CAT19ME PDF file, gives you these informational files here. A point to check on. In the 1-inch diameter column here, it shows wall thicknesses of various types because they're being very precise about some reason. Now, the outer diameter is just called 1 inch. Now, normally I don't trust that, so I checked it. 0.81 inner diameter with 2 layers of that thickness literally adds up to 1 inch. They're very consistently giving you a straight answer by saying 1 inch is 1 inch. Well, what is 1 inch outer diameter? It's literally 1 inch. Imagine that, keeping to some sort of standard. Now, again, Emphasis added. Companies that don't waste your time deserve your money. And again, if you're dealing with salespeople that want you to call them when they could answer a simple question easier, the salespeople shouldn't be deciding your company's policy. Just saying. Thank you, Aircraft Spruce. Totally not an endorsement. Let's move on. How many different how many different types of tubing exist? Oh my God, you don't want to open this freaking can of worms. This is ACR, Air Conditioning and Refrigeration Copper Tube Standard. Dimensions and weights are listed. This one tells you the standard size name. Now let's see how consistent it is. Okay, on the far left, half-inch tubing is literally half-inch outer diameter. 1/4 is literally 1/4. And 1/8 is 1/8. Holy shit. And 3/4 inch matches. Yeah, it's literally not wasting your time by being dumb as dog shit. If it says 2 inches and 1/8, it literally is 2 inches and 1/8. It's not screwing you over. It's done. The hell's going on here? So anyway, and also on the web page itself tells you that it has annealed versus drawn over mandrel piping. When it's drawn over, it's work hardened, and if you want it annealed, that's an extra step, and it will change the wall thickness, and it will change other things. It goes from 30 to 32 because it shrinks in length and thickens up. The inner diameter goes from being 0.315 to 0.311, and the outer diameter goes from 0.375 to staying at 0.375. What that means is it's being kept inside of an outer tube diameter pipe to keep it from changing size that way, and it has a tendency of squeezing it towards the inside while it's being annealed, softened, and made able to be coiled and twisted. Makes it much more malleable. The drawn type is stiff and rigid, but it's seamless. Anyway, that's at coppercanada.ca PDFs 28E PDF. And that file is going to come up a couple of times. This is an excerpt. And they have English and French, which means you're going to get defects and errors because people are going to do stuff back and forth. But it includes millimeter information if you need it. Again, not an endorsement. Here's ACR HVAC copper tubing sizes. Yes, those angry, nasty people that work in your building complaining about how the air conditioning should have been designed properly instead of by some idiot. This is engineersedge.com, fluid flow, copper tubing, HVAC size chart, number 13182. Oh my God, that's how many pages they've got? Anyway, here we are. And it's consistent. It really is. It 1/4 inch is 1/4 inch, half inch is half inch. They have different thicknesses. You find more information on one website than another, but you can find it. You just have to look. Here we go with the color coding chart for the printing that goes on the outside of the copper pipe. Red, blue, and green equal drawn but not annealed, then annealed at one thickness and annealed at another. And there's DWV, which is drain, waste, vent, which is a different type. It's usually fairly large diameter stuff. And this includes the wall thickness on one column and the inside diameter another, because damn it, that's what I was looking for. It's nice that they tell you the theoretical weight per foot, or the wall thickness. And also the original version of this also included the cost, because they're trying to sell you something. But the first thing I want to tell you is, here are our dimensions. That way you won't bug us with stupid questions. But half-inch pipe isn't half-inch. 3/8 inch is actually half-inch outside pipe. 5/8 inch is really 3/4 outside. You get the idea. It just keeps going from there, right off the rails. But at least they give you the data. They don't waste my time. And again, that's Copper Canada PDFs 28E PDF single file. And this tells you about KLM and DWV copper tubing, as well as the aforementioned ACR HVAC copper tubing sizes. Now we get to this one that again repeats the same data. And then we get to this one that's color-coded. Again, this is at Peterson's product, copper tubing sizes, 1979 HTM. And this one includes a half-inch inner diameter in type M, red letters. Well, it doesn't include the wall thickness, so this looks like a typo. And here we go again with Gizmology's version of it. It's missing the half-inch at the 5/8 type. So again, we're probably not dealing with the same data here, so it's probably an error. And here we get to seamless electrical conduit dimensions. What the hell is that? That's the pipe that people put power cables in, so the inside of it cannot have rough surfaces that would damage cabling, because that would start a fire, and that's a big no-no. Now, one of these dimensions is absolutely not like the other, but one of them has some similarities. Now, the one in the middle called GRC or RMC stands for galvanized rigid conduit or rigid metallic conduit, but they're the same thing, and the dimensions on them match or are very close to matching or are identical to standard cheap pipe like black iron pipe and that sort of thing. They're the standard pipe dimensions. They use standard pipe fittings, but they're made seamless. But the inner diameters match. For instance, the 1-inch pipe has an inner diameter just slightly over an inch at 0.049 bigger. And the 3/4 inch outer diameter is about 1 inch, but it's actually 0.050, which means they can interference fit with each other if you sand them or thread them into each other. They're a special case that's used so that you can do that. This idea of the pipes being able to thread into each other was originally probably how pipe fitters were supposed to do things. If they needed to make a fitting, they would just cut off a section of the larger diameter and refit them, but they threw that out, and eventually all the standards went to shit. But a fun thing to point out is that for standard pipe tubing, what they start off with is 1/10 inch pipe at the 1/2 inch pipe diameter. They use 1/10 inch thick metal tubing or metal sheet. And then they roll it up and weld it and make it that diameter on the outside, 0.840. Now, if they start off with a thinner material, like let's say a little under half that diameter, it obviously ends up with a smaller outer diameter, and they use the same size metal bar mandrel on the inside to get the dimensions to match. And it's close enough that you can still thread this stuff. It's thick enough, there's enough there that you can thread it and use standard pipe fittings, but it's not going to fit as good. But this is standard piping. Now, intermediate metallic conduit, IMC, is right in the middle. It starts off with a dimension that's halfway between them. Between, let's say, 42 and 104, it's 0.68. So it's kind of in the middle. It's basically two of those thicknesses almost. It's a little bit smaller than that. And it ends up with an outer diameter that doesn't match the others here, but it's a different diameter, different thickness. And it can be threaded, but the electrical metallic tubing here can't actually. It's too small to get the threading to fit. Now, intermediate metallic conduit is not used very much. IMC is not found very well. I want to point out something very annoying about electrical conduit dimension types that are listed. GRC and RMC are used interchangeably when they're the same type, and it's also the same as standard water pipe tubing. It's just seamless. And it's galvanized. Both of them are galvanized usually. But that can also include stainless tubing and aluminum, and the aluminum looks the same. That's something to note if you're looking up these dimensions. Here we go with EMT only, and it tells you weight per pound, dimensions in inches and millimeters, all the data you need, and that's kineticnoise.com, seismic design, electrical design data. Okay, anyway, it gives you more data, and it is consistent. And here we go with GRC, RMC, aka standard pipe. Okay, let's skip that. I mean, it tells you some data here, but, it tells you the cross-reference. Yes, you people in metric land, those aren't the actual dimensions either. That's right. It uses trade size designator in metric, which doesn't match either. Yes, even the snooty world of metric, doesn't really use the actual dimensions. I know these are close, but they're not. 1 inch is not 27 millimeters. It just isn't. And the 1.315 really isn't either. That's not really nobody uses a standard that matches except apparently HVAC people who said, screw it, we're going to use real numbers. Just saying. And they did it for copper pipes. Here's IMC again and another chart on kinetic noise. Now we get to PVC, polyvinyl chloride. It's a weird world here. They introduce Schedule 40 and Schedule 80. And the next one up you would think would be Schedule 160, but they use Schedule 120. And the outer diameters on these do match. The 3/4 inch is the correct one, and this is 0.84, so that's correct. But the inner diameters don't match on Schedule 40, which is usually considered standard, at least not exactly. They do kind of, but it's not quite. You're not supposed to be able to get a PVC tube, and get 0.81 anything, because that would be bad. Yes, a 3/4 inch Schedule 40 PVC tube is the right dimension to make your flare gun barrel, because it has to be plastic and or constricted at the 2 inch mark. Just saying.